Hi children, welcome to Vidhyalakshmi YouTube channel. Today we are going to discuss about the topic called as terms related to the spherical mirrors. So in this, what are the various terms they are having? So the various terms in the spherical mirrors are pole, center of curvature, radius of curvature, and then principal focus, or we'll be calling it as a focus, and then focal length, principal axis, and at last we are having the aperture, right? So these are the various terms we are having in case of the spherical mirror. So we can discuss one by one what are the various terms and there and how we need to represent in case of a diagram. We'll just go along with that. So first, what is the meaning of the word pole? So where it is going to locate in the spherical mirror? So the pole is going to locate on the spherical mirror at the center point. Clear? So the center point of the spherical reflecting surface, or else simply we can call it as the mirror. Clear? So the center point of the spherical reflecting surface of the mirror is called as the pole. So in case of concave, the pole is going to locate over here. So this point is going to consider as the center point in the spherical mirror for a concave. And if you are taking a convex, so this will be the pole of a convex mirror. So it is, if you are seeing over there, that point is located at the center of the reflecting surface. Either it may be a concave or it may be a convex. Clear? The next term, what you are having is about the center of curvature. We know that the spherical mirror is made from a sphere, right? For that sphere, one center point will be there. So what is the name of the center point? The center point of the sphere is called as the center of curvature. So we know that from which only the mirror has been made. So from this, what you can conclude? So the center of curvature is defined as a center point of the spherical mirror in which the mirror it has been a part. And then, so where it is going to locate? If you are taking a concave, the center of curvature will be located in front of the mirror. So the center of curvature will be located somewhere over here. And if you are taking a convex, the center of curvature will be located behind the mirror. So that point will be calling it as the center of curvature. And next term, what you are having is the radius of curvature. So what is the meaning of the word radius of curvature? The distance between the center of curvature and the pole is called as the radius of curvature. So the distance between these two, that is the center of curvature and the radius of pole, is called as the radius of curvature, and radius of curvature is denoted by the symbol capital R. Whereas in this case, so this will be the radius of curvature denoted by the symbol capital R. So the next term what I am having is the principal focus, or I will be calling it as the focus. Sometimes they will be calling this one also as a focal point. So what is the meaning of the word focus? Clear? It is the point where the reflected rays either actually meet. So in which type of mirror it will actually meet? In case of a concave, it will actually meet, or else it will appears to meet. In which case the reflected rays will appears to meet? In case of a convex. That is called as the focus. So if you are checking over in a concave, the reflected rays will actually meet at one point along the principal axis. So this point will be calling it as the focus of a concave mirror. Whereas if you are taking a convex, so here the reflected rays are diverging and you are making them to meet, or else you will be calling it as the appears to meet. So along the principal axis, so this point will be calling it as the focus, right? So, and next term what you are having is about the focal length. So already we said about the radius of curvature, the distance between the center of curvature and the pole, that we will be calling it as the radius of curvature. Here you are going to say about the focal length, certain length between what and what, the length between the, or else you can call it as a distance Between what and what? Between the focus and the pole. So that length we will be calling it as the focal length. That length we will be calling it as the focal length. In one case, the focal length will be positive, and in one case, the focal length will be negative. So how I can say that the focal length is a positive and how I can say that the focal length is a negative? Based upon the sign convention rule. So based upon the sign convention rule only, we can say that either the focal length is positive or the focal length is negative. So already we know that one rule is there, all the distance must want to be measured from the pole. So whenever we are measuring from the pole towards your right is taken as positive. And whenever you are measuring the distance from the pole towards your left is taken as negative. If you are checking in this diagram, so this point is going to act as a pole for a concave mirror, and this point is going to act as a focus for a concave mirror, and this length only we will be calling it as a focal length, which is denoted by the symbol small f. Right. So if you are checking over there in this diagram, the focal length is located from the pole towards the left side. Towards the left. Already we said that the distance from the pole towards the left must only be taken as negative. So then the focal length of a concave mirror is negative. The focal length of a concave mirror is negative. Likewise, if you are checking as a concave, here if you are checking over there, so this is going to be the pole, right? And this point will be our focus, and this length only we will be calling it as a focal length. If you are checking over there, the focal length is located towards the right from the pole. Already we said that the distance from the pole towards the right is taken as the positive. So the focal length of a convex mirror is going to be positive. Clear? And next term what you are having is about the principal axis. So what is the meaning of the word principal axis? It is just an imaginary line which passes through the center of the mirror by joining the center of curvature and the pole. Yeah, that is called as the principal axis. So if you are checking in this diagram, one imaginary line is passing through the center of the mirror by joining the center of curvature and the pole. So this imaginary line we will be calling it as the principal axis. This imaginary line we will be calling it as the principal axis. Clear? And last term what you are having, it is about the aperture. So how we can define the aperture? Aperture is defined as the distance between the two ends of the spherical mirror. I mean the distance from this end to this end, or else we can also call it as a diameter of the reflecting surface. If you are checking over there, this is looking like a sphere, right? So the midpoint which is passing through the sphere is considered as the diameter. So this distance only we will be calling it as a aperture, or else we can also call it as the diameter of the reflecting surface is called as the aperture. Right. So these are the various terms we are having. We'll just have a recap of that. So first term we are speaking about the pole. So what is the meaning of the word pole? It is a center point of the spherical reflecting surface is called as the pole, right? So this point is considered as the pole, denoted by the symbol capital P. And then we know that the mirror, right, it is obtained from a sphere. For that sphere, one center point will be there. That center point only we will be calling it as the center of curvature, the center point of the sphere in which the mirror is just a part. Clear? That point we will be calling it as the center of curvature. And next term what you are having, radius of curvature. The distance between the center of curvature and pole is called as radius of curvature of R, capital R. And then next term what you are having is about the focus, right? So what is the meaning of the word focus? The point where the reflected rays are either actually meeting or appears to meet. In case of concave, it will actually meet. Whereas in case of convex, it will appears to meet. So where it is meeting? Along the principal axis. So this point only we will be calling it as the principal focus, or we can call it as a focus, or sometimes we can also call it as a focal point. For this also one distance will be there. What is the name of the distance? The distance between the focus and pole is called as focal length, denoted by the symbol small f. Clear? The focal length of a concave will be negative. Why? Because it is located towards the left from the pole. So we are taking it as the negative. And the focal length of a convex mirror will be positive. Why it is positive? Because it is going to locate towards the right from the pole. And next term what you are having? Principal axis. So what is the meaning of the word principal axis? It is just an imaginary line which is passing through the center of the mirror by joining the center of curvature and the pole, is called as the principal axis. And last term what you are having? Aperture. What is the meaning of the word aperture? The diameter of the spherical reflecting surface. That means from this length only we will be calling it as the aperture, or else you can call it as a distance between the two ends of the mirror. That means from M to N. That distance will be calling it as the aperture. We'll just solve some questions which is related to the concept what we discussed now. So the first question is the distance between the pole and focus is called as dash. Option they gave it as radius of curvature, focal length and focus. So here we are speaking about the distance. That means there is a certain length. So what length it is going to be there? The distance between the pole and focus is called as focal length. Second question. The imaginary line which passes through the center of the mirror by joining the center of curvature and pole is called as dash. Option they gave it as focal length, principal focus and principal axis. We know that principal axis is the imaginary line which is passing through the center of the mirror by joining the center of curvature and the pole. So the answer is going to be principal axis. And third one, if the focal length of the spherical mirror is 20 centimeter, what will be the radius of curvature? We know the relation R will be equal to 2 times of F. That is nothing but called as a radius of curvature is twice of its focal length. So in the question, they gave the focal length of the spherical mirror. They didn't mention any specific type of mirror, either it is a concave or it is a convex. They just mentioned only the spherical mirror alone, so that we no need to bother about either our answer it is positive or negative. Just you are going to substitute the values over there in place of F and you are going to find the answer. So R will be equal to 2 into, what is the value for focal length they gave? That is 20. So 2 into 20, that will be equal to 40 centimeter. So the answer will be option number C, 40 centimeter. And then next question. First, what is the ratio of the focal length and the radius of curvature? So from the relation only you are going to derive R is equal to 2 times of F. If you are checking over there, they are asking what is the ratio of focal length and the radius of curvature they are asking. So you are going to find F by R will be equal to, so the R will go this side and 2 will come over here. So 1 by 2 it will be there. Clear? So how we can write? So F by R will be equal to, if you are dividing 1 by 2, we'll be getting it as 0.5. So you can write it as f is to r will be equal to 0.5. Or if you are not simplifying this one and if you are just writing it as f is to r will be equal to 1 is to 2. Either you can write it as 1 is to 2 or 0.5 based upon the options what they gave. If you are checking over there, the options what they gave over here, it is 0.5 is there. So the answer will be 0.5. Next, what is the ratio of radius of curvature and focal length? Radius of curvature and focal length. Same formula, r is equal to 2f. In the previous question we solved, they are asking the ratio for the focal length and radius of curvature, whereas in this case they are asking the ratio of radius of curvature and then focal length they are asking. Clear? So we are going to take the f to the other side. So r by f will be equal to 2 by 1. So you can just write this as r is to f will be equal to 2 is to 1, or else you can write it as r is to f is equal to simply 2. So based upon the option, what will be our answer? Our answer will be option number C, that is 2. Next question. The focal length of a concave mirror, either it is going to be positive or it is going to negative, or neither positive nor negative. So based upon the sign convention only we can say, if you are checking a concave mirror, the focal length will be located towards the left from the pole. From the pole towards the left means it must want to be in a form of a negative. From the pole towards the left, it must want to be a negative. And next question, the focal length of a convex mirror, it is going to be either positive or negative, or neither positive nor negative. So if you are checking a convex, the focal length will be located towards the right from the pole. So from the pole towards the right means it must want to be a positive. So the answer will be option number A. And next question. Sorry. Yes. The geometric center of the spherical mirror is called as dash. So the options: center of curvature, pole, focus they gave. So what will be your answer? So the answer will be pole. So in the question what they are asking, geometric center is something called as the center point of the spherical reflecting surface is called as the pole. So the answer will be option number B. And next question, the distance between the pole and center of curvature is called as dash. Options: radius of curvature, focal length and aperture. So that distance will be calling it as the radius of curvature. The distance between the pole and center of curvature is called as the radius of curvature. And next question number 9. If r, what is the meaning of the word r? R is nothing called as a radius of curvature. So in the question they gave it as r is equal to 30 centimeter. In the previous case we solved that they just mentioned it is a spherical mirror, but here if you are reading the question carefully, they gave it as a concave. So we need to check either it is positive or negative based upon the sign convention rule. So based upon the sign convention rule, for concave we know that f value will be in the form of a negative. F value will be in the form of a negative. So in the question what they are asking? They are asking what is the focal length. So what is the relation? R is equal to 2f. I need f alone. So f is equal to r by 2. R by 2. So what is the value for r? R in the question they gave it as 30 by 2. 30 by 2 will be equal to 15 centimeter. So what will be your answer? Plus 15 or minus 15? So for concave already we said that it is in a form of a negative. So the answer will be minus 15. So what will be your answer? Option A or B? Our answer will be option number B. F is equal to minus 15 centimeter. And last question, the point where the reflected rays are actually meeting is called as dash. Actually the point where the reflected rays are actually meeting along the principal axis is called as dash. So that point we will be calling it as, option they gave it as focal length, B option they gave it as focus, and C they gave it as principal axis. So what will be our answer? Our answer will be focus. Clear? So here in this actually meeting is in a case for a concave. Yeah, okay students. I think the concept what I discussed today's session, it will be clear. Thank you to all.